Hi, welcome to Virtual CB1A. This is Miss Rena and we are now in section 4.4. Lapit na tayo matapos sa trigonometry. This is circular motion, linear and angular speed. So radian measure and arc length can be applied to the study of circular motion. If you are studying physics this semester or kung nag-take na kayo ng physics course ngayong college na kayo, then you can relate on the formulas that we are going to discuss in this section. In physics, the average speed of an object is defined as the average speed is equal to the distance traveled over the time elapsed. So, say for example, we have an object that moves along a circle of radius r. Halimbawa, ito yung object natin. Kunyari, ano siya? Car. Ayan. Yan. Car yan. Say for example, we have a car. And that car is traveling a distance s over a period of time t. So, from this point, nag-travel siya papunta dito sa point na to. Ayan. Halimbawa, ito yung bahay niya. Tapos pupunta siya sa school. Yan. So, the distance he covered from his house to the school is defined by the letter S. And then, of course, that time elapsed from the moment he left his house hanggang sa makarating siya dun sa school is given by the time t. So, what do we mean by time t is equal to 0 here? So, sa initial point niya, 0 pa yung time kasi hindi pa siya gumagalaw, di ba? And then, as he moves along this arc, nag-cover siya ng certain na time. So, we don't know, it is unspecified yet. We don't know the value of t, but we know that it is greater than 0 kasi gumalaw siya eh. So, nag-consume siya ng time. So, then it makes sense to define the average linear speed v of the object as, so v is equal to s over t. Now, why do we call this linear speed when it looks like an arc? Okay, so let's clarify this one. If you have a circle, halimbawa ito yung pinakamagandang explanation dyan. Kuha kayo ng tali o kaya ng anything na bilog na pwede nyong putulin. So, pwede naman na kuha kayo ng tali, tapos gawin nyo siyang bilog. Ayan. So, di ba pagka nagtali ka, tapos bilog siya, meron kang mga arc dito. But, if you cut the thread that you formed as the circle, halimbawa, kinat mo siya dito. Ayan. Kinat mo siya at this point. Tapos, if-inlaten mo siya ulit, magkakaroon ka ng straight line, di ba? Okay, so that is why, even though this is called an arc, we define it as the linear speed. So, even though nag-cover siya ng arc. Kasi arcs, when flattened out, or circle in general, when flattened out, will form a line. Kung arc lang yung target mo, then it is a portion of the original line. It is a segment inside the full circumference of your circle. So, yung full na circumference ng circle mo, ito yung line na yon. So, yung arc niya, syempre, portions nitong line na to. I hope I was able to make it clear. If you have any question, just reach out to me. Now, let's go to angular speed. So, dito sa angular speed, may bago ulit tayong symbol na i-introduce. So, this symbol here, unahin ko na para dire-diretso tayo mamaya. This symbol here is omega. So, this is the Greek letter omega. So, let theta be the angle swept out by the object in that period of time. Okay, so this is theta. Yan. Ito yung central angle that was covered by your movement. Okay? Nung nag-cover ka ng linear speed, syempre, nag-cover ka rin ng central angle. Kasi may na-cover ka na arc eh. So, nakabuo ka ng central angle based on your movement. So, then we define the average angular speed omega of the object as, so that is theta, wherein theta is a central angle, over the time elapsed t. Okay? So please take note of the two formulas that we introduced. We have v is equal to s over t, or distance traveled over the time elapsed. And for angular speed, we have theta over the time elapsed t. So angular speed gives the rate at which the central angle swept out by the object changes as the object moves around the circle, and it is thus measured in radians per unit of time. Wherein ang linear speed naman is measured in distance units per unit of time. For example, feet per second, kilometer per hour, meter per second, centimeter per minute. Yan. So the word linear is used because straightening out the arc traveled by the object along the circle results in a line. Ito na nga yung ginawa natin kanina. Pag in-straighten out mo yung circle, if you flatten it out on a surface, you will end up with a straight line. So the circumference of the circle will cover a certain distance sa straight line. So that the usual definition of speed as distance over time can be used. So we will usually omit the word average when discussing linear and angular speed here. So since the length s of the arc cut off by the central angle theta in a circle of radius r is s is equal to r times theta, so we see that, so for the linear speed, v is equal to the speed over, or the distance s over the time elapsed t, and we know that the arc length s is equal to the radius times theta. So substitute natin si radius times theta, or the measurement of your angle in radians, over time, which is then equal to theta over t times r. Ano si theta over t? Si theta over t ay yun yung omega natin, angular speed. So, if you are looking for the linear speed and you don't have the value of the distance traveled yet, so you can use v is equal to the angular speed times r. Okay? Okay. So, yun yung relationship between the linear speed and the angular speed. So, you can substitute the value of the angular speed to get the value of the linear speed. So, that is linear speed is equal to the angular speed times the radius r. So, let's look at one example. Ayan. So, before we go to this example, sulat muna natin dito yung mga formula natin para hindi natin siya nakakalimutan. So, si linear speed ay dalawa yung formula. Paste ko sila parehas. Ito yung isa, if your S is not given yet. Tapos ito yung isa, if the distance is given and the time elapsed is given as well. Ayan, meron tayong dalawang formula for the linear speed. And then for the angular speed, ito naman yung gagamitin nating formula. Okay. So this is our problem. An object sweeps out a central angle of pi over 3 radians in 0.5 seconds as it moves along a circle of radius r, which is 3 meters. Finds its linear and angular speed over that time period. Okay, so what are our given values? We have the time elapsed t. That is 0.5 seconds. We have the radius r, which is 3. And we also have the measurement of our angle, which is pi over 3 radians. So, the angular speed, omega, since we have here theta and t, we will get pi over 3 radians over 0.5 seconds. And you have to take note that angular speed, ang unit of measurement nito ay radians per unit of time. Okay, now let's compute. What is pi over 3? So pi over 3 is 3.1416 divided by 3. Kuha lang ako ng calculator. Okay, we have two solutions here. One is by substituting the value, approximate value of pi, which is 3.1416. Pwede rin naman na exact value. So, parehas natin siya i-compute. Dito muna tayo sa substituted na si 3.1416. So, 3.1416 divided by 3 divided by 0.5 seconds. So, that is, kuha kayo calcu, 3.1416 divided by 3 divided by 0.5. Okay, so this is about 2.0944 radians per second. So this is the approximated value. Ano naman yung exact value niya? So for the exact value, gawa tayo ng isa pang computation at on the right side, we have pi over 3 radians over 0.5 seconds. So this is pi over 3 radians times, gamitin natin yung tawag mo dito, rule natin sa fraction wherein we are going to change the operation to multiplication and then multiply this by the reciprocal of the denominator, which is 1 over 0.5 seconds. Okay. So this time we have pi. What is 3 times 3 times 0.5? So 3 times 0.5 is, I guess that is 1.5, 3 over 2. 3 over 2. So we have here radians per second. Hindi pa tayo tapos kasi may 3 over 2 pa tayo dito sa ilalim. So this is pi radians times 2 over 3 seconds. So that is 2 pi over 3 radians per second. Okay? So this is going to be the two possible answers for the angular speed. Isa, approximated value wherein we substituted 3.1416 and the other one is the exact value. We didn't substitute the approximated value of pi. Instead, sinolve natin siya treating pi as a constant. So this is the exact value. Okay? Okay. So, hindi pa tayo tapos kasi linear speed pa lang yung na kukuha natin. Doon naman tayo sa angular speed. Since we already have the value for W, we can now use the second formula, omega times R, to solve for the linear speed. Duplicate natin tong page na to. Okay. And then, clear lang natin tong isang side. So, dalawa, yung pwede natin gamitin, isang approximated value, isang exact value. But if you use the approximated value in solving for the linear speed, what will you expect about your linear speed? Your linear speed will also have an approximated value lang. So, kung exact value yung gagamitin mo, to substitute, to stand as the value of angular speed, exact value rin ng linear speed yung makukuha mo. Okay? So, let's try and solve for the linear speed using our exact value. So, we have V is equal to the linear speed, omega, times R. That is 2 pi over 3 radians times, we have here 3, radians per second times 3 meters. So, dito naman sa linear speed, ang hinahanap naman natin na unit ay distance unit or unit of distance over the time elapsed. Okay, so dito we have 2 pi radians times 3 meters. So 2 pi times 3 is of course 6 pi meters. So since wala namang unit talaga si radians, pwedeng dito na tayo mag-settle sa meters over 3 seconds. Or, since 6 is divisible by 3, divide na natin siya, we have 2 pi meters per second. Okay? Okay, so let's check. Okay, so here we have the same answer. Ito siya. So, 2 pi meter per second. Parehas tayo ng sagot. And on the book, ang ginamit ay exact value rin for the angular speed. We have 2 pi over 3 radian per second. Let's try another example. Okay, so we have example 4.15. An object travels a distance of 35 feet in 2.7 seconds as it moves along a circle of radius 2 feet. Find its linear and angular speed over that time period. So before we decide kung sino yung unahin natin, si linear speed ba or angular speed, let us enumerate or enlist the given first. Ano yung mga given natin? That will give us an idea kung sino yung uunahin nating isolve. So ang una nating given, an object travels a distance of 35 feet. So distance is S. So this is the distance. Meron tayong S which is 35 feet. Next we have a time elapsed. T is equal to 2.7 seconds as it moves along the circle of radius is 2 feet. Okay. Now, let's try to solve for their values. So, dito, ang given lang natin na formula ay tatlo. We have V is equal to S over T, or the linear speed is equal to the distance over time. And obviously, since we have both S and T, we can instantly solve for V. So, let's solve for V, or the linear speed. That is equal to 35 feet over 2.7 seconds. Get your calculator. Plug in 35 divided by 2.7. So we have 12.962963, or approximately 12.9630 feet per seconds. Okay. Now, how can we get the value of the angular speed? Wala tayong theta. So, how can we do that? So, by making use of the second formula. Since we have V is equal to W times R, or W omega times R. To get the value of omega, we have to use multiplication property of equality and get rid of R on the right side. So, multiply both sides by 1 over R. On this side, tanggal na si R. And on the left side, you will be left with V over R is equal to the angular speed. Or, this is... Omega is equal to V over R. Ayan. So, dito, extend na natin yung formula natin. This is also equal to V over R. Okay? Now, let's try to solve for its value. We have omega is equal to, our V is 12.9630 feet per second. And then on the denominator, we have 2 feet. So what will happen with our unit of measurement feet? It will cancel out. Now let's solve for 12.9630 divided by 2. 12.9630 divided by 2. You will end up with omega is equal to 6.4815. And since angular speed is in radian per unit of time, this should be written as 6.4815 radians per second. Okay? Okay. So, ganun lang siya kasimple. Let's check if my solution is correct. Yes. Sa solution natin dito, rounded off lang siya to the nearest hundreds. So, meron lang siyang 2 decimal points, rounded off to the nearest 2 decimal points. While, in the solution that we did here, meron tayong 4 decimal places. Great. Now, let's go to... Ito na, example 4.16. Ilang example pa to? As you can see here, malapit na nating matapos yung book. Oh. Konting-konti na lang. Yes. Konti na lang nga. Ayan. I think this is going to be the last example for the day. Kamali ako ng paste. Okay, but at this point siguro naman familiar na kayo dun sa mga formula natin, 'di ba? So linear speed we have V is equal to S over T, which is also equal to pag wala kang tawag mo dito. Pag wala kang S, pwede rin namang omega times T. Or R. R pala. Omega times R. And for the other one, we have omega is equal to radian over unit of time. Okay, angle, theta, over t, which is also equal to omega v over r. Okay? Check nga natin. Ayan. So, tama naman. Now, let's look at this example. An object moves at a constant linear speed of 10 meter per second. Aba, ang given kagad sa kanya ay linear speed. 10 meter per second. Around a circle of radius 4 meters. Ito yung mga given niya. How large of a central angle does it sweep out in 3.1 seconds? So, the time is 3.1 seconds. Okay, so paano natin to i-solve? So, meron kang V, meron kang R, meron kang T. And you are only looking for the central angle theta. You're not even looking for the omega. Okay. So, start na tayo. Unahin natin yung pagkuha ng angular speed. And then, pag nakuha na natin si angular speed, here, we are going to substitute its value to this formula. And then, to get theta, so para makuha natin si theta, we have omega is equal to theta over t. Yung central angle, let's get rid of t here. So, that is equal to, using multiplication property of equality, omega t, or t omega, pwede rin naman, is equal to theta, or theta is equal to omega times t. Okay. Unahin natin, ito, V is equal to omega times R. To get the value of omega here, we can use this one. V over R. So, omega is equal to V, which is 10 meter per second, over our R, which is 4 meters. What will happen to the distance unit? It will be cancelled out. So, W is equal to, what is 10 over 4? 10 over 4 is, ayun na naman gumana nung utak ko. So, 2.5. Okay. We have 2.5 or 5 over 2 in lowest terms. Sulat na lang natin dito 2.5 radians per second. So, bakit may radians na naman? Don't forget that the angular speed is in the unit radians per second. Okay? So, now that we know the value of W, let's use this other formula here. Theta is equal to omega times T, or yung mukhang W, to get its value. So, we have here 2.5 radians per second. Dito ko muna siya isusulat para makita nyo ng maayos yung interaction ng mga units natin. So, imbis na isang diretso siyang line, radian slash second, ginawa ko siyang radian over second. Parehas lang naman yan. Gusto ko lang na mas malinaw nyong makita yung interaction ng units natin. Now, for the time, that is 3.1 seconds. So, what will happen to our unit of time? So, second over second, canceled out na siya. All we have to do to get the value of the central angle is to multiply 2.5 and 3.1, retain the unit radians. So, 2.5 times 3.1, we have 7.75 radians. Okay? So, let's check. Ayun, 7.75 radians. Tama naman yung value natin. Dito, mas ano siya, Mas shortcut pala yung ginawa niya. Sa akin kasi ang ginamit ko ay dalawang computation. Kinuha ko muna yung 10 over 4 before ako nag-multiply with 3.1. Yung ginawa niya dito, diretso na. Yan. We have different solutions, but both of them will give you the same answer. So I suggest that you also check this solution from the book and then see kung saan kayo mas comfortable sa pagsasagot. Okay? Now, let's go to... Parang sabi ko, di ba, ito na yung last. Pero tingnan pa rin natin to. In many physical applications, angular speed is given in revolutions per minute, abbreviated as RPM. So, to convert from RPM to, for example, radians per second, notice that there are 2 pi radians in 1 revolution and 60 seconds in 1 minute. We can convert n revolutions per minute to radians per second by canceling the units as follows. So, n RPM is equal to n revolutions per minute. Ito yung RPM natin. Revolutions per minute times 2 pi radians over 1 revolution times 1 minute over 60 seconds. Now, we are going to cancel out the units that are the same. So, in the numerator, we have revolution. In the denominator, meron tayo isang revolution. So, canceled out na sila. In one of the numerators, we have minute. In the first factor, in denominator, we have minute ulit. Canceled out na siya. You will be left with n times 2 pi radians over 60 seconds, which is n times 2 pi over 60 radians per second. So this works because all we did was multiply by 1 twice. Converting to other units for angular speed works in a similar way. Going in the opposite direction, say from radian per second to revolutions per minute, it will give you n radian per second is equal to n times 60 over 2 pi RPM. Okay? Okay. So, as I've said earlier, cut na natin siya at this point. Pero sige, discuss natin tong example 4.17. Copy ko lang siya sa kabilang page. Okay, so I have transferred here a copy of sample 4.17, yung dalawang gears natin na given. This is the problem. A gear with an outer radius of r sub 1 is equal to 5 cm moves in the clockwise direction. This is the bigger gear. Ito mas malaki. Causing an interlocking gear with an outer radius of r sub 2 is equal to RCM. So, yung teeth nila nag-overlap or nag-interlock. So, yung teeth nitong larger gear, nag-interlock siya with the smaller gear every time that the first gear moves clockwise, and then yung smaller gear moves counterclockwise at an angular speed of 25 RPM. So, meron tayong angular speed for the smaller gear, which is 25 RPM. The question is, what is the angular speed of the first gear or the larger gear? So, set up natin yung relationship nilang dalawa. Start tayo dun sa mga given. So, larger gear. Ano-ano yung alam natin kay larger gear? So, yun nakasulat dito. We have the radius, which is equal to 5 centimeters. For the smaller gear, alam natin that it has a radius of 4 centimeters and an angular speed of 25 revolutions per minute or 25 RPM. Ang hinahanap natin ay si angular speed of the larger gear, omega sub 1, na nawawala. Okay. So, set up natin yung relationship nila. Pag gumalaw, itong unang gear, syempre, gagalaw din tong kabila kasi nga interlocking yung teeth nila. Just imagine that these two are closer. Tapos, mas obvious. Medyo malayo kasi yung nakalagay dito eh. Parang hindi sila magta-touch, di ba? Pero pag closer sila, magta-touch yan. So, automatically, pag gumalaw tong malaking gear, gagalaw yung maliit na gear. At pagka gumalaw yung maliit na gear, gagalaw din si malaking gear. Ayan. So, the movement of one will cause a movement on the other. So, here, since they are going to move simultaneously, so after a certain unit of time, kung gumalaw si larger gear from t sub 0 to a certain unit of time, so t sub 1, gagalaw din itong maliit. Tapos kapag tumigil ito, titigil din yung isa. And vice versa. Kung ito yung gagalaw, gagalaw tong malaki. Kung ito yung titigil, titigil yung malaki. So, at exactly the same time. So, the time that that one of the gears will cover will also be the time that the other gear will cover. Ayan. Yung movement nila ay laging the same. Hindi sila pwedeng gumagalaw yung isa, nagko-cover ng distance yung isa, tapos yung isa stagnant. Hindi pwedeng ganon. Pag gumalaw yung isa, gagalaw yung isa. Pag tumigil, titigil yung isa. In other words, their time will always be the same. Okay? And since their times will always be the same, so the time that is covered, yung distance nila, ayan. So, kung gagalaw to, halimbawa, ganito kalayo. Yan. So, exactly, ganito kalayo rin yung igagalaw nung kabila. Yan. Hindi pwedeng nag-cover to ng certain distance, tapos ito, mas maliit yung i-cover na distance. No. Even though this is a smaller gear, parehas lang sila ng distance na i-cover at the end of the time t. So, their distance covered, S sub 1 and S sub 2, will always be the same. Now, what is the relationship of the distance and the time? So, based from the distance and the time, we can get their linear speed, right? So, if you are going to flatten out the arcs that were covered by the first gear and the second gear, pareha sila ng distance ng line segment. So here, V sub 1 is equal to T sub 1 over S sub 1. And we know that T sub 1 is also equal to T sub 2. And S sub 1 is equal to S sub 2. Right? Therefore, V sub 1 is equal to V sub 2. So we can write here, V sub 1 is equal to V sub 2. Okay, what do we know about V sub 1? Let's make use of the given values that we have initially. So we are given with omega sub 2 and r sub 2. And we know that if we are looking for the linear speed of the smaller gear, we can make use of omega sub 2 and r sub 2. The linear speed sub 2, the linear speed of the smaller gear is equal to its angular speed times its radius. Same with the bigger gear. Meron din tayong omega sub 1 or the angular speed of the bigger gear times its radius. Ayan, medyo okay na tayo. Kasi isa na lang yung nawawala. We have r sub 1, given yung radius natin for the larger gear. Next, we have r sub 2, given yung radius natin for the smaller gear. And we also have the angular speed for the smaller gear. So let's substitute the values. We have W sub 1 times the radius of the bigger gear, which is 5 centimeters. Ayan, which is also equal to, we have angular speed of the smaller gear, 25 RPM. So we have 25 RPM times radius sub 2. Radius sub 2 is 4 cm. Okay. How can we find for the angular speed of the larger gear? So get rid of 25 cm. Let's multiply both sides by 1 over 5 cm. So here, tanggal na si 5 cm, 5 cm. And on the other side, you will end up with 25 RPM times 4 cm over 5 cm. So, pasimplihin muna natin siya. What will happen to the unit centimeters? It will be canceled out. So, centimeter, centimeter, 1 na lang siya. You will be left with the unit RPM. We have here angular speed is equal to 25 times 4 is 100. We have 100 RPM over 5. Giving us 100 divided by 5 is 20. So 20 RPM is the angular speed of the larger gear. Ayan, ganyan lang siya kasimple. Okay? So I hope I was able to make this word problem clear. This is the end of our discussion for this section. Check natin yung susunod. Ano na tayo? Chapter 5 na tayo. Graphing and inverse function na tayo. So, dito gagamit tayo ng Desmos. I doubt that I can do the video lecture dito sa PSBC kasi ang bagal-bagal ng internet. So, probably, I will be recording this weekend sa bahay kasi we have a better internet sa bahay. Okay, so this is going to be the end of the lesson. And check lang natin kung ilang pages pa yung kailangan nating i-cover ha. Ayan, hanggang 152 lang tayo eh. And we are already in page 103. 50 pages na lang. Eh, ang dinidiscuss lang natin ay definitions and examples. Hindi tayo naglalagay ng mga sample na problem like this. Hindi tayo nagsosolve ng mga exercise problem. So, siguro mga 30 pages na lang, tapos na tayo sa trigo. Okay? So, thank you very much for having this lesson, thank you very much for listening to this video discussion. And good luck on your exam. See you next time. Bye!